Hello everyone, my name is Hrittik Banerjee. I am a data science and machine learning intern at StarTech Academy. So today in this video, I am going to describe you the solution of problem 3 of task 2. That is, you can see the problem statement here. That's John, who is an HR analytics manager at STA IT Services. He wants to predict the CTC or salary for new hires. So we have to build a linear regression model in Python for that. So let's dive into the code. First of all, we are going to import the necessary libraries, that is NumPy, Pandas, Seaborn, Matplotlib, .pyplot. And after that, uh, for linear regression, we are going to use standard scalar, matrix, R2 square, mean absolute error, mean squared error, and linear regression from import them from a scalar module. Then we have to load the datasets. The training datasets as train and testing dataset as test. Here we don't have to do the 80-20 splitting because two datasets are given differently. It's good here. Now first to look at the head of training dataset, we can see that there are three categorical variables and there is one variable s number which is totally unnecessary. That is serial number actually. So in order to do linear regression, we have to make the categorical variable into numerical variables. So first we are going to drop the s number variable and then we're going to transform them into numerical variable. It is very easy to transform categorical variable into numerical variable. Just use pd.getDummies code and pass the columns name of categorical variable and the data set. So we have done that, and as you can see that the categorical variables are gone, and in their places there are new different numerical variables. That is, college has tier 1, tier 2 and tier 3 categories. So these three categories are in three different variables. This is dummy variable coding. So let's look at the test dataset. We can see there are, in the test dataset there are also three categorical variables, but these categorical variables are already transformed into numerical variable in this dataset, and we don't have to do any transformation in this dataset regarding categorical to numerical. We just drop the college, role and city type, these three categorical variables from this dataset. So 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 as we have done that, so this is our now test dataset after dropping, and the train dataset. But we can clearly see that the train and test datasets are different, because in the test dataset there are 9 columns and in train dataset there are 12 columns. So in order to do linear regression, we have to give the train and test dataset as same number of columns with same order. That is, the arrangement of columns must be same, and with the same column name. So let's do that. First of all, dropping unnecessary columns from the training data, that is the college tier 3, role executive and city type non-metro. Then after that, the two data sets has 9 number of columns, but we have to arrange them in same order. So we arrange the test dataset head, that is column names. And after that, we're going to rename them, and finally after renaming, we can see that the test dataset and the train dataset, you can see in the screen, have same number of columns in same order and with same column name. So now our data is finally okay. But let's check the characteristics to be sure. First of all, let's check the characteristics of train dataset with the .info function. What we can see here, note that here there's object. This is an object function. Previous CTC and CTC are of object data type, that is of string type. So we cannot use it, because in linear regression we must use the numerical values. This linear regression model cannot deal with string values, so we have to turn them in float values first. Let's do that. After turning them into float values, we can again check the info, and now it is float 64, that is object type is now in float 64 type, it's transformed. And now let's check the information about test dataset, and yes, it is okay, there are int and float, so we can use them in the model building, no problem. Let's see some descriptive statistics using the dot describe function. So what we can see that there is no null values and nan values here. And one more thing, from these descriptive statistics, it is very easy to say that the datasets, train and test datasets, are quite similar to each other, very similar, because I'm seeing everything quite same. So let's now let's split our dataset in, for x train and y train we have to split our dataset, the feature variables in training dataset, and x train, that is independent variable or feature variables dataset, and finally the target variable y train, that is CTC value. Okay, now doing the same for the test dataset. For ease of computation, we use the scalarization method, that is we use the standard scalar function on x train and x test, and use sc.fit transform on them. Now our data set is totally ready to do the linear regression. The first, let's create a linear regression model. We have to create the model using the linear regression open close parenthesis function. After creation, we have to train it using the training dataset, that is feed the x chain and y chain values on it. So now our model has been created and then trained. Now we just have to predict based on this training. We predict, our model predicts these values on the x test dataset, that is using the feature values of test dataset, our model predicts the target values on of the test dataset. And let's print the model's intercept, coefficient value, and score. Its score is actually the r square value, so let's print it. So actually, to get a better view of the linear regression equation, I have used SymPy. So you can see here x1, x2, x3, x4, the attributes are all in order. That is, if you say the trade for the train dataset, you can see the first variable is x1, and then second variable's value is x2. So if you put the values of this in from the test dataset, and you can actually get the value of the predicted variable, that is CTC, from this equation. Now let's create a data frame with with two columns. One is predicted CTC value, and the next is actual CTC value. So predicted CTC value and original CTC value, the two columns. We are creating this just to get a better visualization. Okay, then we are using this pair plot function. It gives us in the diagonal, we have the histogram of predicted CTC value and histogram of original CTC value, and in the off diagonals we have the scatter plots. In this figure you can see the scatter plots quite clearly, that in x-axis we have predicted CTC value and y-axis the original CTC value, and we can see clearly that these values don't match quite good, and they are scattered. So our model is not a good fit. Let's see it more clearly with some statistics. With R2 square, the R2 square value of this model is 0.608, that is quite similar to 0.61, and 0.61 is not a good fit for the model. The mean absolute error is 6159, and the mean squared error is quite very high. RMSE value is 7853. So there is very variation in the predicted values and the original values. We might use different train data set for our model building or different methods, but yes, that's the task. We have created the linear regression model, we have predicted the values, and this is the solution of problem number 3 of task 2. It's a quite good learning. I am going to thank StarTech Academy for giving me this opportunity, and thanks for watching. Okay, bye.